Today's lesson is on lines and circles and measuring the angles that are caused by pairs of lines interacting with circles. We're going to start by talking about individual lines intersecting with circles and how those lines are either secants, chords, or tangents depending on where they are in relation to the circle. Then we're going to talk about pairs of lines and see how the intersection of those lines is a point, and that point can either be on, inside, or outside the circle. If the lines meet on the circle, we're going to realize that the formula to figure out that angle is the arc divided by 2. If they meet inside the circle, then it's the sum of the arcs. I add them and divide by 2. And if they meet outside the circle, I'll see that they subtract the arcs and divide by 2. Now let's look at how a single line can intersect with a circle. And there are only 3 possible ways that a line and a circle on the same plane can interact. Firstly, the line may cut the circle at 2 points. And there's an example right there. The line may touch the circle at only 1 point. For example, that line is just touching the circle at 1 point. Or the line may miss the circle entirely, like that. Now, our 3 vocabulary words for what these lines could be is the first one is called a secant. That line in red cuts the circle at 2 points and is called a secant. Contained within the secant is the chord, which right there is in blue. The chord is a line segment that has its endpoints actually on the circle. So you'll see that every secant has a chord within it. Finally, in green, we have this is called a tangent line. A tangent just barely touches the circle. So now we've talked about how single lines can interact with a circle. Now let's talk about a pair of lines interacting or intersecting with a circle. And there are only 3 possible places for a pair of lines to intersect in relation to a circle. The point where they intersect can meet on the circle, for example, two chords or secants, and it looks like that. There you'll see my 2 lines intersect on a point, and that point is actually on the circle. The lines can meet inside the circle. Again, I could have 2 chords or secants, and there's an example of 2 chords meeting inside of the circle. Finally, the lines can meet outside the circle, and I could have 2 secants that look like that, a secant and a tangent that look like that, or 2 tangents that look like that. But either way, any of these examples, the point is the intersecting point is outside the circle. So now we'll talk about measuring inscribed angles. Inscribed angles are what happen when the lines meet on the circle. So if the lines meet on the circle, again, it looks something like that, then the angle formed, there's the angle we're talking about, it's equal to, so we'll set that equal to something. The angle's arc, so there's the arc of that angle, divided by 2. So there's my formula. The angle equals the arc divided by 2. Now let's do an example to show how we can use this formula. So imagine I want to try to find that angle, so I'll call it x. And I know it's my arc divided by 2, but what is my arc? And let's say my arc is 114 degrees. So if I take 114 divided by 2, I get that x equals 57. So that angle there is 57 degrees. The key thing to remember, the takeaway from this slide, is that if the lines meet on the circle, then I take the arc divided by 2. If they meet on the circle, I take the arc and divide by 2. Now we can talk about angles that meet inside of a circle. And so if they meet inside of a circle, then the angle, and there is the angle I'm talking about right there, the angle is equal to the sum of 2 things, and those 2 things are my intercepted arcs. So in this case, it would be that red one and that blue one. If I add up the value of that red arc and that blue arc, and then divide by 2, I'm going to get the value of my angle. So if lines meet inside the circle, the angle formed is equal to the sum of the intercepted arcs divided by 2. So the blue arc plus the red arc divided by 2. Let's do an example and see what that means. So we'll call that x, and I know x is equal to the sum of, now we'll say the blue is 71 degrees, so I can plug in 71 there, and the red is 113, so I can put in 113 there, divide that whole thing by 2. So x equals, if I add up 71 and 113, I get 184. Take that whole thing divided by 2, and so my answer is x equals 92 degrees. 92 degrees. So that solves the problem, but let's say I wanted to do that one right there. Well, I would have the same answer because I would again take the red and the blue. Or the other way to look at it is, what types of angles are these? And the answer, of course, is that those angles are vertical to each other, or they are vertical angles. And what do we know about vertical angles? Well, what we know about vertical angles is that they are congruent, or their measures are equal. So if the purple angle on the right is 92 degrees, then the purple angle on the left is 92 degrees. But we can still know more, because I could ask you, what type of angle is that green angle? And hopefully you would know the answer. Is that it's a straight line or a straight angle, so it's 180 degrees. And so now if I was asking about, well, how big is that orange angle that I've drawn right in there? Well, the orange angle is equal to the purple angle, or I'm sorry, the green angle, which is the whole 180, minus the purple angle, 92. 180 minus 92 equals 88. So that is an 88 degree angle there. And then finally, if that's an 88 degree angle, that is a vertical angle to it, so that is also 88 degrees. The key thing to remember is if they meet inside, then I add the arcs and divide by 2. If they meet inside the circle, I add the arcs and then divide by 2. Now we can talk about angles formed outside of a circle. And if lines meet outside of the circle, then the angle itself is equal to the difference of, so it's going to be a difference of two things, the difference of my intercepted arcs divided by 2. So let's again do an example to see how this works. If I'm going to call my purple angle x, and I know it's the difference of two things, and those two things are, if my red angle is 123, I can put that in, and if my blue angle is given as 61, I can put that in, and take those things and divide by 2. So x equals 62 divided by 2, or in this case, x equals 31. So it's 31 degrees. The key thing to remember from this slide is that if they meet outside the if the lines meet outside the circle, then I subtract the arcs, then divide by 2. If they meet outside, I subtract the arcs, then divide by 2. Let's do it again, but instead of doing two secants, we'll do a secant and a tangent. But everything stays the same. They meet outside the circle. It's the difference of the two arcs divided by 2. So what is my angle equal to? It's the red angle minus the blue angle over 2. Now I have a secant and a tangent. Nothing changes. It's the difference over 2 if it meets outside. So let's do an example. If I'm trying to find x, and I'm given the fact that my red angle is 202, and my blue angle is 122, if I subtract those and divide by 2, I get 80 over 2, or x equals 40. So the answer is x equals 40. So now we've done two examples of being outside the circle. And again, the key thing to remember is if it's outside, I subtract the arcs and then divide by 2. Subtract the arcs and divide by 2. Now what happens if I've already done an example of two secants and a secant and a tangent? What about if I have two tangents? Again, everything's the same. If they meet outside the circle, it's the difference of the intercepted arcs divided by 2. So if I want to try to find that angle there, I know it's equal to the red arc minus the blue arc divided by 2. So if I'm told that my red arc is 231 and my blue arc is 129, I simply subtract those two and divide by 2. So in this case that would be 102 divided by 2, or 51. So x equals 51 degrees. So it doesn't matter whether I have two tangents, one tangent and a secant, or two secants. If the lines meet at a point outside of the circle, then I subtract the arcs, then divide by 2. If they meet outside, I subtract, then divide by 2.